One of Java's data types that we haven't spoken about up until now is the array type. This basically is a way of representing a collection of data which is effectively inline. So if we imagine a collection of ints, which could, let's say, correspond to some people's ages. 37 and 67. This basically comprises 4 different people's ages. So in this case, this could be 2 of my cousins, myself, and my mum. And let's just see what that looks like when we print it out. And that's interesting, because rather than printing out the individual ages as you might expect, instead of which we just get this strange output here. Now, what do we think that might mean? Well, up until now, we've sort of assumed that objects should have a natural representation in text, but we haven't really delved into that in any detail. And when we've tried to print out the array here, we've got something slightly unexpected. So let's take a couple of minutes to look at that in some more detail. For example, let's look at the person class, which we talked about in earlier sections. This has a first name, a last name, an age, and another person who's the mother of the person being talked about. And if we look at this bit of code, what we can see is we've always just printed out the full name or the age, but we've never actually tried to print out the object as a whole. So if we just get rid of some of this earlier code from earlier on. So let's just do a printout of the person object as a whole. So this was a person object which was supposed to, in some silly way, represent me. I think for now we'll just comment out that bit of code. So when we run this, what you might expect is that what we'll see is a representation of each individual field. So let's see what happens when we run the code. Well, that's interesting. We didn't get any output which looks like the contents of the object, instead of which we just got this strange string here, which is the name of the class, because remember that class names are always fully qualified, and our person object lives in the package called first project, and the class is called person, so this is clearly the fully qualified name of the class, and then there's an @ sign, and then there are just some numbers and letters afterwards. And if you know something about the history of computing, you might recognise that this probably is a hexadecimal number, which is base 16, which is a very common format which is used in computers. If you haven't come across it, don't worry about it, but if you recognise it, then sure enough, that's what it is. Well, that's a bit disappointing, because how do we know? Because obviously we have 2 person objects that we were dealing with in some of the earlier sections. So let's just print out the other one as well. The object which should be representing my mum. Ah, this is disappointing, because while we're still printing out these 2 objects, all we have is a slightly different number to represent them. We can't actually see what's inside. So how are we going to fix this problem? Well, it turns out that there's a very natural way in Java to do this. And in fact, we can use our old friend Control-I to generate some code. And the method we're actually going to generate is the toString method, which is a way of automatically generating a natural method to make a simple textual representation of an object. All IDEs will provide you with a generation option to automatically produce a toString. So there we go. So we have this toString method, and it returns a string. So now when we rerun the code, what we find is we now have these much better representations. And so we can actually see there's also a slight bug in the code, because if we look at my object here, well, first of all, I'm not 50, but that's not the bug. The bug is that, of course, my mother should be set to the mum object. So in fact, what we need to do is fix that. See, and now when we rerun it, we can see actually that my mother is set to the right thing. This is quite interesting, and the observant people in the audience might have noticed that something slightly strange has happened here. Because before we defined the toString method, and let me just comment it out so you can see this, we just had this strange behaviour with these numbers and the hexadecimal after the person. Once we define toString, the same bit of code, and notice that all I've done is I've just changed a bit of code in person. I haven't touched anything in the main class, and yet the same code is now producing a different result. Now, if that seems slightly strange, then there's a reason for that. We'll return to this issue in the next section when we talk about inheritance and method overriding. But that's just a throw forward, so that when we talk about these things, we'll come back to this example and we'll see this in more detail. Okay, so that's all well and good, but we were talking about arrays, and our arrays, unfortunately, still aren't doing the right thing. But at least now that we've seen what happens if you don't define a toString method, so let's comment that out again, and now you can see the objects and the array, they look like they're being treated in kind of the same way. So what we really want is a way to produce a sensible textual representation of the array. So let's see how to do this. Well, I don't know what we should do here, so let's have a think. Let's look around in the Java doc. This is quite often a good thing to do, is if you don't know what to do, go and have a look through the Java doc, because quite often you'll find a useful class in there. And one package which you should definitely know about is the Java util package. We'll be talking about that quite a lot in this section. But I happen to know that there's a nice helpful class here called arrays. And this basically enables us to provide lots of useful methods to help us work with arrays. And buried down here, there's a lot of methods on the arrays class. But buried down here somewhere is arrays toString. You see there are a bunch of different methods here. So let's try one of those out. So arrays toString. Oh, and of course the idea is hopefully telling us, what's this arrays class? I don't know about it. Alt enter just says add the import. So yep, we add the import so that now we can refer to the arrays class just as arrays. We don't have to put the java.util in front of it. And let's run that. Yeah, and now you can see that the output actually looks like we expect it to. There are the 4 elements, the 4 different ages that we have. So we can now print out the array as a whole. But what happens if we want to access individual values from within it? Well, Java provides some helpful syntax to let us do just that. In fact, what we can do is we can print out, let's print out the first element of the array. And that should actually say ages. See, this is why we like IDEs, because they always tell us when we make our mistakes. So let's print that out, and that should print out the first element. Now, hang on, something's gone wrong here, because that's actually printed out 22, which is in fact, if you look, it's actually the second element. So why is that? Well, this is kind of a long-standing bit of computer history. Arrays have always traditionally, in C and languages which are derived from C, of which Java is a very good example, have started from 0. So we always number upwards from 0. So in fact, if you want the first element of the array, you actually have to say it's actually the 0th, like that. And you see, sure enough, when we say give me the 0th element, you actually get this one. This is all to do with the way that C deals with memory, and it's all to do with where you start from versus an offset. So if you imagine that the array is at one and the same time both the whole array and a reference to the first element in the array, that you then add an offset to determine your location within it. So an offset of 0 is the first element, an offset of 1 means you find the start of the array, you move 1 place forward, and then you take the value there. So actually the second element is the element at offset 1. And Java's arrays are always arranged like that. To show how to work with arrays, let's just do another quick little calculation here. So let's double average. I0 is less than, I'm going to show you a little additional bit of syntax here. Ages. Let's get rid of this blank line. And you see the IDE is complaining about something, and that's basically because we haven't initialized this value here. So let's do that. Ages.length. And so hopefully you can see that this is a fairly simple calculation for the average age of the 4 that I've provided there. And sure enough, average age of 35. Wow, that's not so bad. Now, there's a couple of things here which we can probably pick up on. First of all, we've got the plus equals operator, which basically just says take the value that you already have, add what's over on the right hand side to what's on the left hand side, and update the value with that new total. So it can easily be rewritten as this. So that's all it means. So when you see the plus equals, it's just really syntactic sugar for this expression here. So let's put that back in. But the second thing to notice is that we're treating ages almost as though it's an object, because we've got dot length, and as the ID has picked up, it's marked it out in green, and as we know, that's how the IDE indicates to us that we have a field. So it's almost as though ages, which is an array of ints of primitive type, also has fields, almost as though ages was in some sense an object. And in fact, Java's arrays do sit in this somewhat halfway house. They do behave like objects under some circumstances, even when they're simply an array of primitive types. Let's step through the code one line at a time. We're starting here where we set up the variable AVE, which is short for average, which will be ultimately the home where we're going to keep our average value. Now, let's think about how we'd calculate an average for these ages if we were going to do so manually. What we would do is we would add them all up, and then we'd divide by the number there are. Now, the number there are is 1, 2, 3, 4, which is effectively the length of the array. And because arrays live in this strange world where they're half objects and half not, they do have a property on them, effectively a field, called length, which tells you how many things are in the array. So when we divide by the length at the end, just as we always do when we're creating an average, that's the number that we divide by. So in this case, it will be 4. But we also need to go through the array and add up all of the ages that we find. So what we do is we use this variable AVE effectively as a temporary. It's a temporary variable that we're using as a working area. We go through and one by one we add in ages with the subscript I. So when I is 0, we'll get 14, and that will be added to AVE. When I is 22, when I is 1, rather, we'll get the value 22, which will be ages 1. When I is 2, we'll get 37, and finally when I is 3, because remember we're starting from 0, the length is 4, so we'll get the values 0, 1, 2, and 3 for I. And one by one, we'll pick out individual values from the array, we'll add them all into AVE, and finally, we'll divide by the length to get the overall answer, which, if we run this again, should be 35. And notice, of course, that AVE is a double, so again, we get this telltale sign where it finishes .0 when we print it out. One of the other really useful helper methods that's provided by Java is the ability to sort data. Now, as it happens, the ages I've given actually are already sorted. So let's just jumble those up a bit. Let's put 14 in here. There we go. Those are now nice and jumbled. So is Chrome gone? And let's see if we can find, there we go, a sort method. So this method will sort the array into ascending order, which means the smallest will be at the start, and then at the end will be the largest. And a couple of things to notice about it. First of all, like virtually everything in math, in arrays rather, it's a static method. It also returns void. Now this is interesting because if we want to think about how we would write a sort method, there are two different ways of approaching it. Either we can say, what I want you to do is to take the thing that I've given you, the unsorted array, and I want you to sort it, and I want you to return me a new copy which is sorted, but don't do anything to the version that I've given you. Alternatively, you can say, here is the copy, I want you to sort it in place and reorder it, and I don't need to give you anything back. You don't need to give me anything back because the array that I handed you, you're actually going to modify and you're going to mutate and you're going to actually work on it in place, treating it as though it's its own temporary work area. And in fact, as we can see, and the telltale sign is always in the signature of the function. So the return type of sort is void. Now, because that means that there is no return value, it means we can't possibly be doing the first of those two alternatives. We have to be doing sort in place because there's no way for us to return a new value. We just don't return a value from sort. So in fact, we will actually be sorting in place. So let's see this in action. Arrays.toString again. Now let's do arrays.sort. Let's do this again. And then let's just not print out the average age. Yep, and sure enough, you can see that there are the unsorted ages that we start with, and after that we have the sorted array after we've done the sort. There's one other place where we've actually already met arrays, although we might not have realized it at the time, and that's the string class. If you think about it, a string is just a sequence of characters. So it probably doesn't surprise you to learn that under the hood, the string actually contains an array of char, which is the contents of the string. So let's take a look at how that might work. So where is the string class? Oh, we'll go from here. And here's another little tip, which is that actually NetBeans provides you with the ability to navigate to where source comes from. And that does actually include the source of the platform classes. So here we are. We're actually now starting to delve inside the workings of Java itself. So this is the string class. And if we look at the package, sure enough, it's java.lang. We're actually looking at the source code of one of Java's classes itself. Now, there's a lot of complications in here and a lot of things which we don't need to deal with necessarily. But the thing that we do want to look at is this. Private final char value array. So what this means is there is an array of char called value which is used for the character storage. And on the line above, you can see it says very clearly this value is used for the character storage. So arrays are very, very useful, and they're fundamental even to how classes as simple as string operate. So it's good to know how to work with them. And let's have a quick look. So we can, of course, sort strings as well, or sort arrays of char. So let's have a go at that. So down here, we can char array. Let's call it letters. And notice that we've got this syntax for providing an array literal. So we've got A, F, Z, punctuation mark, capital L, and let's say capital T. I notice that there's a slight distinction here. When we're talking about a single character, we actually use single quotes rather than double. Double quotes are used for enclosing strings, as we've seen throughout all of our system printlins in the code that we've already written. The single quote is only ever used to denote a single character, as we've done here. So let's do that. So let's just basically cut and paste a bit of code here. And instead of ages, let's do letters for everything. And then that one there as well. Let's run that, and hopefully we should see the letters being sorted. So here they are in their original format. And then basically, the way that the sort algorithm works, it's an alphanumeric sort, but it also takes into account punctuation as well. Now, there's something quite interesting that we haven't really talked about yet. And it's kind of hiding in plain sight in the code that we've written. And it's this. Up here, we call the sort method, and we call it on an array of int. But down here, we call the sort method again, but this time we're calling it on an array of char. So how does that work? How can we call the same method with different data types? We've always said that Java is a statically typed language, and surely the compiler should complain about that. The answer is actually in the Java doc. As you can see, there are a whole bunch of different sort methods. This one takes an array of long. This one takes an array of int. And in fact, if we go all the way back up to the top, we can see that there are actually a lot of different methods which actually have the same name. But what distinguishes them is the data types that they take in. Here's the sort method for the array of char. Here's the one for the array of int. And the Java compiler is actually smart enough to notice what data type is being taken in and to figure out which method is meant. And this is called method overloading. So the same method, or conceptually the same method, can have the same name but can take different arguments. There are actually different method bodies and different blocks of code that get executed. The fact that they share the same name is okay because the compiler is always able to disambiguate based upon the type of the data that's being passed in. As we've seen, strings have a definite length. But what happens if we try to move outside the range of those strings? Those arrays. Let's have a look. So let's, for example, I think we can probably comment some of this out for now. Control-Shift-F. And instead of the arrays.toString, let's just do ages. Now we know we've only got 4 of them, so if I ask for the 6th age, what do we think will happen? Well, let's run the code and find out. That's interesting. We've hit another one of these exceptions that we've met a couple of times before. This one is called an array index out of bounds exception. And what that means is that Java has detected that we're trying to go outside of the realm of the array, and we're trying to access something which just isn't there. The array is only 4 numbers long, so asking for the 6th, offset 6th position, which is of course actually the 7th element of the array, just doesn't make any sense because the array only has 4 things in it. So rather than attempting to carry on, Java has actually flagged this and has raised this as an exceptional condition which we have to deal with. Now this is in stark contrast to earlier languages such as C. C provided a much more direct way of working with the computer's memory, and if you attempted to move outside the bounds of a C array, you just get whatever data happened to be next door to it in memory. This of course was not very good and led to all sorts of horrendous security problems. And so when Java was being constructed, it was determined that rather than having that strange and potentially undefined behavior, instead we'd enforce some strict range checking, and if you ever try to range outside an array and go over the size that the array actually contains, you will in fact trigger this exceptional condition, this array out of bounds exception. Up until now, we've been dealing purely with arrays of primitive types, but in fact, arrays can hold anything, including object types. So let's just tidy up some of this code here, get rid of some of the stuff we won't need. And instead of cheating and just having an array of ints where we're looking at people's ages, of course we already have a useful class. We have the person class, and that already has an age on it. So let's finally get rid of our old friend the while loop. Let's get rid of him. You see, and of course I'm actually really 38, so we'll do that. My mum's 67, and let's bring my dad into the picture as well. So there's my dad. There's a bug here because it's actually my mum that's 67 and not me. And we should also set Dad's age as well, so let's do that. I'm not sure they're going to be very happy about me telling the whole world how old they are, but if you're watching Mum and Dad, I'm sorry. Okay, so now we have 3 different people. There's me, there's my mum, and there's my dad. Let's put them in an array. So just as we did before with the primitive types, we set them up like this. And let's call this array my family. And I suppose I should also apologise to my sister and brother who also aren't here, represented here. Well, that's interesting because I've got mum and dad, but I've also just called the person variable that's going to represent me. I've called it P. Well, that's not very good. So as we're here, let me just show you another quick shortcut. So if you come up to the refactor menu, the first entry we have here is rename. So I can use this to rename any part of the code. So instead of P, let's rename everything so that it's Ben all the way through. There we go. And that's very easy to do. You can rename anything using that refactor menu item, which is the keystroke for which is just Control R. And you can rename methods, you can rename variables, entire classes. You can do a lot with the rename option. Okay, so here we go, and now I've got an array which consists of my family, just to show that I haven't cheated. Let's click there. Let's just print that back out again, just to make sure that everything is completely working as it should be. And you see what's happened is we've actually deactivated this nice toString method. So all it's doing at the moment is printing out those strange references we saw before. So let's fix that and rerun it. Yep, and there we go. And notice that because I've actually set my mother to be my actual mother, she actually gets printed out twice. But I didn't set mothers for my mum or my dad. So they actually have this strange special value which is called null. Okay, and null really means missing data. Because if you look on the person class, you see I've said that in addition to a first name and a last name and an age, there should be a reference to another object which is representing whoever your mother is. And while age can be defaulted to 0 quite easily, when we're talking about an object, there's no real sensible default value to set it to, because the data's just missing. And so when that happens, Java inserts the special value called null, which means missing data. And in fact, handling nulls and the whole class of exceptions known as null pointer exceptions are a very big topic in Java, which we'll come back to several times. So yes, and now you can see here that my mother's mother is set to null, because that data we just simply haven't provided it when we set this class up. Okay, so that's all well and good. Now let's recreate our age average. So we set that up like this. And there's a special form of the for loop, which I'm just going to mention here, which basically says, go over the whole of the array one at a time And rather than having a specific index variable like I that we've previously seen on for loops, we're just basically saying, give me the people one at a time and put them into this temporary variable called p. This is exactly the same. This is complete. The bit of jargon for it is syntactic sugar, but this is exactly the same as my family.length. Length is my family. See that those two bits of code are exactly the same. So, but rather than having all of this additional extra boilerplate, we can actually just say this nice shorter form. And I think that's much easier to read. And then, of course, what we do is inside the loop, we just add up p dot get age my family dot length. And now let's just print out that average. You see, and sure enough, the average age of my family is between 57 and 58. So that kind of concludes our brief introduction to arrays. Arrays are an extremely useful data type, and it's well worth digging below the surface and finding out what else you can do with them, especially looking in the arrays class for more useful helper methods.